And the mouse you'll have to reach a little bit.
That's fine. Okay. So welcome to my introduction to R. It's supposed to.
Okay. Maybe you click and it goes. Okay.
Okay. I had to throw this in there. What is R and who designed it? R is a open source programming language that's designed for statistical computing and graphics. Open source being it's free. That's a good reason people use it. It was designed by two guys in New Zealand. These are the two gentlemen that designed it. This is Robert Gentleman and Ross Ihaka. I can't say his name. It was created in 1993, and the reason I had to include that is because it was an implementation of the S programming language that was created by John Chambers, and no, there's no relation, because I was asked that in class.
Okay. Let's just do that. We don't need special color scheme. Whoops. Why did it do that?
I have no clue.
Okay, let's do it again. Here we are.
Okay. Okay, now a lot of people want to know why they should learn R. I think it's really important to start utilizing R more frequently in classes and stuff. R is being used in academia, it's used in the government, it's used in the industry. There's a lot of places that are looking for R experience. As you can see, the employers list statistical tools such as R in their job descriptions. I actually pulled these two job descriptions right off of Indeed jobs. And a lot of people are requiring skills with experience in R. And some of them, like, you can't get the job without R experience. So R is utilized in many different countries and has a large user community. Questions regarding on how, what, where, when, why to use R is usually available online. You can Google, how do I enter this? And you can find it, and it's ready and available. Like I said, it's really important that it's free. There's programs like SPSS and other software that costs a lot of money, and R does that for free.
Right.
So. Yes. Okay, this is our interface. I'm not sure how familiar you are with the computer, but an interface is a device or a program that allows the users to communicate with a computer. You're also going to hear it called the R prompt command line, or you can open it up in R GUI. There's many different ways you can access the R interface. Basically, it is an interpreted language. What that means is when you put something in, or you put a statement in or a command, it's going to spit something back out at you. So that's just like a abbreviated definition or layman's terms. So yeah, okay, hold on. Sorry, it's been a long day. You can enter in commands directly into the command line. So like if you want to enter in data, you can do it via the command line. Or if you want to take an Excel sheet or an SPSS printout or something of that nature, you can actually read it in through a text file.
Okay.
Okay, now this is R Studio. It's a free and open source integrated development environment. It's a fancy way of saying it's a great work area for R. Here you notice you still have your R console down here in the corner. I don't know if you can see, but
yeah,
it's
you
in
don't
the
need
corner.
to say much about this. This is just like MATLAB. It's no different from MATLAB.
Oh, fantastic. Yeah. Oh, is it exactly
the same layout?
Oh, fantastic.
Yeah.
Okay.
So you don't need to say much about this. Jeff, I think we can just skip this, right?
Yeah. Okay, good. I don't know about installing packages. I've never used MATLAB, so I just assumed you didn't have any computer knowledge of R at all. Sorry. R packages and installation. R packages are free libraries of code that's written by the R active user community. That's very important because with the people that I was working with on different projects, because we had group projects as well, through Johns Hopkins, they were actually writing functions and writing code into R for packages, and they make constant updates of these packages. So in the packages, you will pick a package based off of what you're trying to do. It was in the right-hand corner of the thing. Your packages, most of the popular ones that people...
Yeah, this is actually also pretty common. So I think we can skip this.
Okay.
I want to get to more of what you did. This is very... most mathematical software has a feature like this.
Okay. Well, I haven't used a lot, so you have to remember this is
no,
what
that's
I've
fine.
done
If
in
I just let
class.
you know the things, I want to get to the stuff that I think we'll be really interested in.
Okay. The basics of R. I'm guessing that you've seen this a lot. Here, this is your basic calculator. It does all your calculations. You're going to put it into the prompt. It spits it back out.
Right. Okay.
Here, you can create variables, and it'll save the data and utilize it anytime. I didn't know that it's all the same. I'm sorry.
Yeah. So far, everything I've seen is just like MATLAB.
Okay, and it has several predefined using.
Okay.
Does it MATLAB have that too?
No, they probably don't have this.
Okay. Well, here, this is just 3 examples of pi, letters, month abbreviated.
Yeah, MATLAB has pi, but not the other one.
It has a lot of different presets.
Yeah, the predefined things for every software are based on what people think that users are going to use most, basically.
Yeah.
Yeah, and R has a very vast.
Yeah, this would make sense for database because you want to compare letters. So and this would also make sense for database.
Okay.
So that's good.
Okay. Now R provides. I'm guessing this is not new for y'all. Then I'm sorry. There's many ways of storing data. Here, like all this stuff, like I basically created in my computer because this is what we did during the year. Like our job for the first half of the semester was learning what this means, how to put this in. So you can store data and as ordered sequence numbers, character strings, logicals, or factors. So I just pulled off a few. Here, notice that if you want it to be a character, you want it to not be like a variable.
Yes.
You're going to have to use like quotations and all that. I don't know if it's the same.
Okay. Well, this is, there's some new, this syntax is somewhat different from MATLAB.
Okay. So like, does it look the same here in the middle?
Well, I mean, they're equivalents.
There's going to be special things you'll have to learn.
They're equivalents. Like here, it looks like a comment is 2 sharps. Is that right?
Yes. 2 sharps is a comment and it won't affect your code.
Yeah. Okay, and then this C here, I guess that means character, right?
No, the C tells you that it's going to be a string of some sort.
Oh, okay.
The quotations around it tells you that it's a character. Okay. So here, if I want to know, like, okay, so this is a very short, obviously, character string, but and it has 3. I have 3 pets listed. So I can find out what type of string it is by typing the mode in and it'll spit it out. Right. And then I can test and see how many of those pets are named Fido and it'll come back regardless of how long your character string is.
So what does mode pets do?
Mode pets, it just tells you what string you're working with.
What type of object it is.
Numeric or character.
So if I typed mode Y here, what would it say?
It's going to give you numeric. Those are numeric values.
All right. Okay.
Okay, so this is the nitty gritty. This page actually shows an entire project that we were doing.
Okay.
R for statistic courses, I think R is fantastic. R has data sets built directly into packages that you can utilize. I don't know if it does in MATLAB, but you can utilize, in our class, we did mosaic data, and this is the package most commonly used in statistics because it has data that's been accumulated and collected for last 20 years in there. Now in statistical courses, we usually, learn how to calculate mean, standard deviation, variance, median, all that good stuff. R makes these type of calculations really quick and simple. Okay. In order to use a package, you're going to tell it require mosaic data because that's what I was using. Here I put in an option because I just wanted to show up to 3 digits. I didn't want it to go far. And then literally this is after I type this is what you type. You're going to type your mean. Now, in this example, it utilizes the help RCT package to analyze data that was stored in the mosaic data package. The CESD, the Center for Epidemiologic Study on Depression, had data that was stored into it from 2012. The data measured depression symptoms for 453 individuals, which you can see your ends right over here.
Right.
And the values ranged from 1 to 60, with a higher score indicating a more depressive symptom.
Okay.
So what I did is I actually took the mean to find out of those 453, how many, or what was the average score. A standard deviation, variance, median. So I'm not familiar with what MATLAB can do, but it's very easy to pull those data sets. As soon as you use a package to...
Why do you need a twiddle in front?
That tells you what data set it's coming from. It's coming from this data set.
And it's confusing.
Where is it pulling the data set from? Is it stored in the software, or is it getting it from online somewhere?
From Mosaic data.
It's in Mosaic data. It's, well, I think I'm not quite 100% sure exactly where it's all being stored, but I know that R has it built into the packages. So what I think people are doing is they're constantly updating the packages and adding new information, because you can find everything from weather systems to, the average mile of gas, for a particular vehicle. So in order to access those data sets, there's many ways you can go about it. Like if there's something particular you want to do, you can go online and just kind of search or Google the data sets that are available. Through Johns Hopkins, though, they when you purchase their package set or whatever, they include a lot of different data sets. So
I don't understand why you require Mosaic and require Mosaic data.
Okay.
What does Mosaic have that's not Mosaic data?
I'm not 100% sure why it required it. I think that this might be an earlier version and this is a later version. I don't know if you actually have to put both in there.
Okay. So
I just
maybe,
installed it freshly on the computer.
All right. And what confused me here is here you use the twiddle, and here you don't use the twiddle.
Oh, yes. So, there's many different ways, and that's what I'm glad you brought that up. There's many different ways you can enter in data. Like this is one way you can try to find the mean, and I think it's the simplest. But you can also use, you can say with this, get this, do this. Oh, there's more than one way to enter in a command to get something. And the reason that is because different packages are created by different users, and different users create tools to make it simpler and easier.
What happens if you type this in without this one?
Then it's not going to spit it out, because I'm utilizing a stats package through help RCT to get this. It's not just Mosaic data. This is where the data is coming from. Yeah. This is the package that's actually helping me do mean, standard deviation, variation. There's different packages you can use. You might not even need to use the help RCT. I'm not sure.
Okay.
So there's a lot of different packages.
You would think that R would just, once you tell it what to the data set, you would think that mean of the data set would be enough. Without specifying this business.
I haven't tried it. We can try it when it's over if you'd like. Yeah. I mean, we can play with it a little bit. So. Okay. One thing I really, really liked about R was that the histograms.
Okay, I'm gonna have to tell Jordan that we're not ready yet. Hey Jordan, I'll have to call you back. I'm Andrea's still doing her presentation.
Okay, that's fine.
I'll call you back. Thanks,
right.
Bye.
I'm almost done, I promise.
Yeah. Oops.
Okay, with the, once you decide on what data you're going to use and you stick with it, there's a few things, the features that you can do. Like here, I required Mosaic. I just did that so I could remember to tell you, hey, it's Mosaic data.
Okay.
Here, I did a histogram of the data that you had just seen from the previous slide.
Okay.
And here, this data accounts for all 453 people.
Okay.
Well, I wanted to show you how easy it was to separate out those people by sex. So here we have females, here we have males.
Right.
And in that particular package, and for our assignments, we did everything from age to homeless males to homeless females, stuff of that nature.
Okay. Right, good.
But it's very visually, and it's easy to export these. You can export these and use them right away in a PDF file.
Right.
And if you create a markdown file, you can actually publish directly to one of their user communities, or you can publish to the internet pretty quickly.
All right.
Okay. Now here's an example. Like all these like previous slides I was showing you that I was doing. What I did is I actually created a survey through. I didn't want to I kind of wanted to keep it anonymous for the sake of what we're doing in here. But I actually created a 5-question survey. It was a ranked survey for research methods, and I wanted to make it look kind of neat and cool and stand out a bit. So I used R, and I did a little more work than I needed to because I was trying to do something funny, but it didn't work. But here you're basically, I created a markdown file, and then I took like I was saying, data can be imported multiple ways. From this example, I created a CSV file on Excel and it just imported it in. So you can create like a big matricey, and like R is endless. You can do big matricey and it'll show. And then you literally, you're going to set your working directory, which I did. It was in my desktop. And then you can just read the CSV table and literally it'll read it in just like that. Now, what I was trying to do here was something fancy, but it didn't really come out the way I wanted it to, although it did. Here it shows you the headers. I gave it headers, which my Excel sheet didn't have. And then what I was trying to do was actually have it, I didn't want the double, what do you call it? Sharps. But I couldn't figure out how to get them out of there. But that's because I just kind of worked this out. So, but yeah, so you can actually enter in, and this is what the page that once I finished, I actually analyzed it and but he wanted us to do the analyzing by hand because it was a small survey. But I went ahead and printed it out just to make it look pretty. So, but yeah, that's kind of how this works.
All right. Yeah.
And this was done through Shiny.
Okay.
So, introduction to Shiny. She wanted me to speak about this for just a second. Shiny is a package, a web application framework for R. You turn your analysis into an interactive web application. No previous, and HTML, CSS, or JavaScript required.
Okay.
Okay, so what exactly it does, it's a package that you can only get on RStudio.
Okay.
Like with R, you don't have to have like an environment. You can pick a different environment, but the one that we most commonly use in our classes is RStudio. Shiny is only available in RStudio, and it makes it extremely easy to like do interactive web applications. And once again, you're just going to install it from the package page. So I'll show you what it does. Okay, so the reason why Shiny is very popular for professors and teachers to utilize in their classes, because after you download the package, that's all you have to type, and you're going to get a beautiful picture like this. Literally, it has many examples built in that will allow the user to explore the package. Now, notice the sliders here. With Shiny, you're going to actually program in. I don't know if you can do this with MATLAB too, but you program it in, and you will get sliders when you're using Shiny. And you can increase your bin size, lower it, and you'll see what happens on the next page. But so now for our Shiny class project, it took a long time. We explored the wonderful world of R by creating an R Markdown document and utilized the Shiny package. In this particular assignment, we focused on how to use the text editor box. Now, with RStudio, you're going to want to use RStudio versus just like RGUI, because with this environment, the text box is so easy. I don't know if it's like this in MATLAB, but when you go to the prompt box, you can't just erase. And like once you've entered that line, you can't just erase. You'd have to upspace and play with it and wiggle and jiggle. But when you're working with like Shiny, you can run right from the text box. So let's say I find an error right here, I can just erase and rerun the document. So now projects like this, we tried doing it fast, and it took hours and hours and hours because we were new with the project. We didn't understand that even like a space in between words, it's an actual programming language. So you have to get very comfortable with programming. But once we got it to work, there it goes. Our pictures came out something looking like this. As you can see, you can actually view it, what it would look like on a web page from the Shiny app. Once you get it up and you run your document, you can actually publish it from there, or you can view it in like a browser. And once you view it in your browser, it's just going to take on your IP address, but you can look at it and see what it looks like. So now here, let's see. Okay, I'm on a page. Here with the class project, we evaluated geyser eruption durations in minutes. It was in one of the packages that Minnie had found, which she was great at finding. What sets this example apart from the previous one, which we coded ourselves and put it in, was it also allows you to adjust the bandwidth. So here you can adjust the bins, and it's real time. I don't know if you're familiar with that, but so here, we might have it through 10, but if I click on 50, it's going to give me 50 bins, and the bandwidth will adjust accordingly.
I'm not sure what you mean by bandwidth.
This right here, you might, I can't remember exactly what we were looking at here, but...
oh, I see this. This is a Fourier analysis, let's say.
Something of that nature.
So the bandwidth only affects the line. It doesn't affect it. Okay.
Although you could code it to increase or decrease the size of the bin if that's what you're asking.
Well, you did. When you do number of bins, that's what it does.
Right.
That's what it does. Okay. Yeah, I understand.
Okay. Okay, this is my favorite part. This is what I was waiting to get to, and I was hoping Minnie would be in here. Okay, swirl. We did not do swirl in Minnie's class. I did swirl for the first time with John Hopkins. What it is you're going to learn R in R itself, and swirl teaches you R programming and data science like interactively at your own pace and right in the R console. So what it is it was designed by a student at Johns Hopkins because so many students were not passing R programming because it's a required course now. And they were having issues because they'd never probably coded in MATLAB or whatever. So if you install the package, what I did was I had already installed Swirl, but I just wanted to make sure that it was at the latest version. And you're going to want to tell the library that you're going to use the Swirl package. And if you click Swirl with the open brackets like that, it tells you that you're going to start. Now, the reason I like it is because it's very interactive. I don't know about you, but I've seen a lot of students where you get into these interactive quote-unquote programs and they're just randomly clicking buttons. This one requires you to be a part of it. So here it says my name, and then you're going to go. Now it says, do you want to continue with one of these lessons? Yes, you're going to want to do R programming basic building blocks. Okay, now steps for utilizing Swirl. I did this for more so for Minnie because I know she's going to continue using it, but you're going to want to install R if you haven't already, and it has to have the 3.02, which is the newest version. You want to have R Studio, same version, obviously. Install Swirl, load Swirl, install R programming course, and then start the Swirl lesson. Okay, so why Swirl? With Swirl, the user can learn at his or own pace. Now, I just opened the very basic of very basic. Here, it'll give you like a little reading prompt and talk to you. And once you see 3 dots, you're just going to press yes, enter, and it'll tell you you're 11% done. But each time you participate, you're going to have some type of feedback. Now, in the very beginning, it's very simple, like, what happens when you press 5 plus 7? What happens this? It starts very basic for, extremely new users, and then it gradually gets harder. Each lesson is rather short, and the percentage, like I said on the right, tells you what, how much you've completed. Now, each piece of information requires some type of user feedback, so you can't just sit there and go like this forever, especially past the first 2 or 3 lessons. Let's see, almost done. Okay, now it's great for students. I really think I benefited from it because I did they offered Johns Hopkins course to do it. They offered like a point of a point, to participate, and you only needed to accomplish 5 of them. Well, I went ahead and did all 15 because I thought they were fantastic. Another thing that's really good about Swirl is, let's say that you're very stumped and you don't know how to do something. There's a help feature where, so if it gives you a command or tells you to do something and you missed it somewhere along the way, it'll show you how to do so. All right. Now, okay. Let's see. All right. Yes. Okay. So after you complete a lesson in Swirl, it'll ask you if you want to receive credit for completing this course on Coursera, because, like I said, it was created by Johns Hopkins.
Right.
So in this case, obviously, I selected no, but when I did it, I could. So, if you decide to incorporate like R into your classroom or something of that nature, you can actually have students screenshot. And then that's what I was going to get at for many. You can have students screenshot that they actually completed the lesson. So there's no excuse, oh, I didn't know this, I didn't know that. Well, yes, you did, because you completed it. So finally, there's a total of 15 different lessons available on Swirl. Each one's unique, and it totally builds off the previous one. So like, if you're new to R, you don't want to jump down to like 14. You want to start very basic and build yourself up.
Okay.
Yes.
Right, bravo.
Thank you. So I know, I didn't know what you were, I didn't know that it was so much similar to MATLAB.